Hi everyone, this is Mrs. Hayes with Video Notes 4.2, Exponential Growth and Decay. So if you look in the two boxes at the top of the paper, you can see that we are talking about exponential growth on the left-hand side, and you can see the picture growing exponentially as you move from left to right. And on the right-hand side, exponential decay, and you can see the picture decreasing as you move from left to right. So growth is when you have an initial value. Well, wait a minute, you do for decay also. You have to have a starting value, and then you multiply. Remember, it's exponential, so we're multiplying by something that is bigger than 1. So here's an example. The initial value here is, hold on, I'm trying to get a good pen to work here. The initial value is 5. That's why the graph starts at 5. And we're repeatedly multiplying by 2 as we go through the table. You can see it really good at the positive x end of the table. So you're starting at 5, you're repeatedly multiplying by 2. 2 is bigger than 1. And you can see that the graph increases as x increases. As you go from left to right, the graph's going up. In the next example for decay, you can see that we're starting at 5. Our initial value is 5, just like it was on the other table. But our values are starting at 40 and going smaller as we go down the table. So we are starting at 40. Oh, this is not the right picture. Oh, yes, it is, 0, 5. Okay, -3 is way up at 40. -2 is now only, oh, half that amount. So our multiplier is 5. I'm sorry, our multiplier is 1/2. That's between 0 and 1. There's our multiplier. We're multiplying by 1/2. And our initial value in this case was 5. And the y values are decreasing as you increase x. So here's our initial value, and here's our multiplier, multiplied by 1/2. So exponential growth, exponential decay. The number of people, exercise 1 here, the number of people who have heard a rumor often grows exponentially. You know, because people start talking and everybody's getting into this rumor and it just keeps spreading. Consider a rumor that initially starts with 3 people, assuming day 0. So that's why if you look at the table, we have that information. And every hour, so every time this increases by 1, the people who hear the rumor doubles. So I'm reading carefully and I'm looking at the table they provided. I'm going to fill in this table where n is the number who knew the rumor after a certain number of hours. So this is hours, and this would be people who know the rumor. After 1 hour, if it's doubling, there would be 6, double, 12, double, 24, double 48, double 96, and double 96, and you get 192. Graph this situation, and luckily they set up an axis with numbers on it for me. This is x acting like h hours, and this is y acting like a function of h, and we called it n for number of people. The y-intercept is 0, 3. It wanted you to label that with its coordinates. And then 1 is 6, and 2 is 12, and 3 is 24, and 4 is 48. If I'm graphing too fast, you can always pause the video and catch up. And here's your graph. Notice I went into quadrant 2, quadrant 2. This is quadrant 1, this is quadrant 2. And the first question is, why are we only graphing in quadrant 1? So I screwed up. This graph should not go this way. I'm erasing it as we speak. And the reason is, h is acting like the x-axis, right? H up here in the table is acting like x, and time can't be negative. So in this case, it doesn't make sense to say what happened at -1 hours because we don't have -1 hours. Write a formula. So n of h, it's for the number of people who knew the rumor, so n as a function of time is starting at 3, our initial value, multiplying by 2 every hour. So we would start at 3, we multiply by 2, multiply by 2, multiply by 2, and you can see why this becomes exponential. Explain what the 3 and the 2 mean in the context of the problem, which means I need to go back to my table and look at the words hours and people, and the fact that it's about rumors. So 3 is the initial number of people who knew the rumor. Knew the rumor. Notice I didn't just say it's the starting value. And then 2 is the multiplier, but that's not contextual. Every exponential function has a multiplier. This one is the number of people who know the rumor is doubling. So you're doubling the number of people. Use this to predict how many students would know the rumor after 40 hours. Number of people after 40 hours would be 3 times 2 to the 40th. And if I go to my calculator, I might have calculated that somewhere. Let's see. Let me move back a page. Nope. Let's see. Page 1. Okay. What am I doing? 3 times 2 to the 40th? 3 times 2 to the 40th. Enter. Oh, that's a lot of people. Am I going to remember all those digits? 329,853, 329,853, 488-3328, 488. Oh, I forgot already. Oh my gosh, I'm getting so old. 488-3328, 3328. I want to put some commas in here after every third number. Holy cow, that's a lot of people. Is that reasonable? No. I think that's more people than we have in the whole wide world. So it's not reasonable. That's how quickly things spread exponentially. On the next page, let's see, I want a page of notes that's not filled in. Found it. We got this guy named Brian, and he is heading towards a lighthouse in a very peculiar way. He starts 160 feet from the lighthouse. By the way, I know this looks like a windmill, but whatever. Let's pretend it's a lighthouse. On his first trip, he walks half the distance. On his next trip, he walks half of the distance that's left. On each consecutive trip, he walks half the distance of what's left. We are going to model this distance, d, that Brian has remaining to get to the windmill after n trips. Oh, now it's a windmill. First it was a lighthouse, now it's a windmill. So confused. Okay, so anyways, initially at time 0, there were 160 feet to get to the lighthouse. If I take half of that distance, multiply by a half, which by the way is the same as dividing by 2, I would get 80, and then 40, and then 20, 10, 5, 2.5, 1.25 feet remaining to get to the windmill. State the initial value and the multiplier. Well, the initial value is 160 feet. That's the initial value. And the multiplier is 1/2. Remember I said multiplying by half is the same as dividing by 2. But we want to know what we're multiplying by, so it's a half. You could also say 0.5 if you prefer decimals. Graph the situation. All I'm doing is plotting the points. So 0, 160. After 1, we're at 80. First trip down to 80. Second trip, we got 40 feet remaining. Third trip, 20. Fourth trip, 10, 5. And then we're getting so close, I can barely plot the points. Again, if I plotted that too quickly, you turn off the video and plot your points. Using the pattern you developed in E, write a function. All right, so if it's a function, d of n, I need to know my initial value, 160, and my multiplier, 1/2. Hey, by the way, that's decay, and I can tell by the picture and by that fraction being less than 1. And I know that I'm multiplying repeatedly as the number of trips changes. There's my function. By the way, his name was Brian initially, and now they're all of a sudden asking about Gene, but I think they mean Brian. Explain what the 1/2 and the 160 mean. 1/2 is the multiplier, but we already knew that because they asked for that up there. But 1/2 is the taking half the distance each time. Each trip. And the 160 is how far in feet he was away initially. The initial distance from the windmill. When will Brian finally reach the windmill? Never. He keeps getting closer. And when you take calculus, you're going to learn that that's a limit. It happens. He's approaching this value of 0. Y equals 0 is called an asymptote. A horizontal asymptote. It's an imaginary line that you keep getting closer to but never touch. All right, last question. Exercise 3. We're trying to find an equation. They told me it's exponential. So I'm looking for an initial value but not seeing it. So let's look and see what my multiplier is. I don't know what I multiply by. So I could guess by doing 150. Well, not really guess. Find it by calculating 150 over 60. I believe on my calculator I have a page of these calculations. 150 over 60. Yep, it's right there. It's 5/2. As a decimal, that's 2.5. And if you want to test out another one, do 375. Divide by the previous number. Again, you would get 5/2 or 2.5. So when I'm multiplying by 2.5, multiplying by 2.5. Every time this goes up by 1, so you got to pay attention to what this is doing. Every time it goes up by 1, I'm multiplying by 2.5. So divide by 2.5 to reverse the process. And 60 divided by 2.5 is 24. 24. So my function, using the correct notation, would be d of t equals initial value times, remember this means multiply when you put that in front of parentheses, my multiplier, 2.5 to the t. There's your function. Now, if I were you, I would graph that function as a function of x on your calculator, 24, 2.5 to the x, and double check that you have the right table. So I did that on one of these pages, and you should be able to see it. 2, 3, 4, there it is. And look at that, the table is correct. So make sure when you get to class, you know how to use your calculator. Have a good day.